Assalamualaikum brothers and sisters. So this video will be presenting the final amplifier for BJT known as common collector. Okay, another name for it is emitter follower amplifier. Okay, so for common emitter, okay, in the previous videos the output is measured at the collector. Okay, but for common collector the output is measured at the emitter terminal. Okay, and another thing is that the gain is a positive value, whereas for your common emitter the gain is a negative value. Okay, so those are the two differences between these two amplifier. Now you can see here, this is an example of a common collector amplifier. So you can see here the output is measured at the emitter terminal, okay, and the collector is directly connected to your power supply, so there is no RC here. Okay, so that is the common collector configuration. So firstly, in order to calculate the AC parameters, you need to calculate the DC collector current. So you are going to do the DC analysis and BE loop, just get the IC current. Okay, and then you calculate what is R pi, GM, and there is this small R naught. Okay, because VA is given. Okay, VA is given as 80 volt. Okay, now this is the original circuit just now, and you're going to convert into the AC equivalent. So you can see that. Okay, so this is your R pi. Okay, this is your GM/VBE, R naught, and this is your RE. Okay, so your collector is directly connected to VCC. So this is your VCC off and this is your VTH off. Okay, just like your common emitter. Okay. However, the output is measured at the emitter terminal. Okay, so that's why I put a highlight here. The output is measured at the emitter terminal. Okay, so in order to make this AC equivalent a standard amplifier block, where the output side is at the right hand side and the input is at the left hand side, okay, what you need to do is you need to rearrange the configuration here. So this is the configuration just now in the previous slide. I want to make my output on the right hand side, input at the left hand side. Okay, but you can see in the circuit the input is okay, the input is standard, it is on the left hand side. However, my output is here, okay, at the bottom. I want to bring it to the right hand side, right? So I just bring this branch, okay, you can see here, I just bring this branch, okay, this RE, okay, which is connected between ground. So this is my ground to node X, okay. Okay, but when you move a branch, you need to move everything that is associated with that particular branch, okay, because node X is connected to 1, 2, 3 more branches. Okay, so if you start with R naught is connected between X and C, but my X is at the top now, right? So I just draw my R naught. Okay, R naught is connected between X and C. Okay, what else? Beta IB. Beta IB is connected between X and again the collector terminal. So that's my current source. However, because the arrow here is pointed towards X, so this one is also pointed towards X. Okay. And finally my R pi. So R pi is connected between base and X. So what do you think? How will R pi looks like? So this is my RTH, which is connected with B. So this is my B terminal. Okay, so B and X, which means that my R pi will be a horizontal resistor like this. Okay, because this is my base and connected with X. So now that you have rearranged all the components, okay, so that the output side is on the right hand side and the input side is on the left hand side, we can do the steps to calculate the AVOC. Okay, so you can see I labeled a few things here. Your VBE is always the voltage across R pi, so my VBE is now over here, and this is another current I will call this as I0. Okay, and you have the input resistance seen from the base, RIB, which have been introduced in your common emitter with RE, right? Okay, and you have the output resistance for the common collector. Okay, I will go into this R0 a bit later. Okay, there is something unique about the output resistance for your common collector. Okay, so let's look at the steps in detail. So you have 6 steps over here to calculate the AVOC. Okay, so the output side, there are 3 steps, and the input side has 3 steps as well. Okay, so if you look at the first one, the calculation of R equivalent, which is at the output side, so these two are in parallel. Okay, so R0 is in parallel with RE. Okay, so this will become one resistor known as R equivalent. Okay, next is the calculation of I0 at node X. So you can see this step here. At node X, use KCL and get I0, right? So that's what I'm doing. KCL at node X is GM VBE plus VBE over R pi. So if you look at the circuit over here, okay, I0 is equivalent to GM VBE, the current is going in, okay, and this current over here. But this current must be calculated using Ohm's law. You know the voltage and the resistor, so you can find the current using Ohm's law, VBE over R pi. So that's what I have obtained over here. Then you can simplify it like this because GM is equivalent to beta over R pi. Then the third step for the output side is the Vout equation, at which Vout equivalent to I0 multiplied with R equivalent. So you can see here, this is I0 and this is my R equivalent. Okay. So next for the input side is the calculation of RIB. Okay, so you can just memorize this equation, RIB equivalent to R pi plus 1 plus beta multiplied with R equivalent. Similarly, with your common emitter, the input resistance Ri is equivalent to RIB in parallel with RTH. Then this one, okay, VBE in terms of VI using supermesh. So what is supermesh? So supermesh is this, okay, it's defined as the combination of two meshes which have a current source on their boundary. So you can see that we have a supermesh here. Okay, so this is my current source. So I want to calculate the supermesh at this loop here. Okay, so VI equivalent to VBE plus Vout, VBE plus Vout, right? So that's how I get this equation, and I just put in all these parameters over here. And then next is the calculation of AVOC, AVVI equivalent to Vout, and you will cancel out your VI and you will get this open circuit voltage gain equation. This is similar to the steps to cancel out your VI or to cancel out your VBE, doesn't matter, but eventually you will get this equation for your AVOC. So if we go back to the circuit just now, okay, so we just ignore this part first. So we just concentrate from this point onwards. Okay, so the first step is the R equivalent. So R0 parallel with RE is 1.96 kilo ohm. Next step is the I0, the current I0 over here, okay, which is equivalent to GMVBE plus VBE over R pi. Okay, and this is what I obtained. So you can see that I left the answer in terms of VBE because VBE will be cancelled out later. Okay, so the third step is the Vout equation, and Vout equivalent to I0 multiply with R equivalent, and I obtain 60.38 VBE. Okay, so the output side is done. So now for the input side, you need to calculate what is RIB. So RIB is equivalent to R pi plus 1 plus beta multiplied with R equivalent, and I have obtained this total resistance. Okay, next is the calculation of input resistance Ri, which is equivalent to RIB in parallel with RTH. Okay, so that's what I have obtained. And finally the supermesh. Okay, so this is the supermesh loop. Okay, so I have, this is my VBE, right? VBE plus V out equivalent to VI, right? So you can see the loop there. And I have obtained 61.38 VBE. Okay, so now you have done all the 6 steps. Next, we calculate the AVOC. So AVVI equivalent to V out. Okay, so V out is equivalent to 60.38 VBE. This is from your step number 3, right? Then VBE is equivalent to VI over 61.38, which is from your step 6, right? So you can cancel out your VI, okay? And you are left with this equation, AV equivalent to 0.9837, okay? So then only you will connect with the input signal over here. So because there is no load, AVVI equivalent to V out, right? Okay. So VI is equivalent to, look at the input side, you use the voltage divider. So you will get V out over Vs is 0.962. Okay. So you can see that the voltage gain for a common collector is less than 1. So normally common collector is not used to do any voltage amplification. Okay. So normally it is called a voltage follower because it is approximately equivalent to 1. So whatever the voltage input will be equivalent to the voltage output. However, this circuit will be used as current amplifier. So common collector is normally used to amplify current instead of amplifying the voltage. Okay? So let's look at this second example. Okay. So this example, again, the output is measured at the emitter terminal. However, this time you have RL. Okay. And of course, this is the input signal lah. Okay. So you are given all these parameters. Beta is 135. VBE on is 0.66. VA is infinity. Okay. So I have calculated RTH and VTH. And you are asked to calculate the DC collector current. Draw the AC equivalent circuit. And calculate the gain V out over V1. So V1 the input signal lah. Okay. So just do the DC analysis first and you will get the collector current. Okay. So calculate R pi GM and the small R naught is infinity because the VA is infinity. Okay. So VA is infinity. So when you draw the AC equivalent, you can remove the R naught. So you can see I don't have any R naught over here. So just the emitter resistor RE and R pi and the current source. Okay, so just follow the steps. So what do you think the R equivalent is going to be? It will just be RE, right? Because there is no small R naught kan. So R equivalent to RE 1 kilo ohm. Second step is the calculation of I naught. Okay, so just use the formula GM VBE plus VBE over R pi. And you obtain 32.43 VBE. And the third step is the equation of V out, which is the voltage over here. Okay, so this is my V out. So just I naught multiply with the R equivalent. So I get 32.43 VBE. Because RE is 1, multiply with 32.43, so you get 32.43. So next, for the input side, the RIB, okay, and then the RI, and finally the supermesh equation, and you obtain VI equivalent to 33.43. Okay, so now calculation of AVOC. So this is the equivalent circuit of a voltage amplifier. So you want to find what is AVOC. Okay, so as I mentioned just now, this is from step number 3. Right, V out equivalent to 32.43 VBE, and this is from step number 6. You will cancel out VI and you obtain AVOC equivalent to 0.97. Okay, so next is the connection with the input signal and RL. Okay, remember I mentioned just now the circuit has RL, right? Okay, so this is the input side, and now you connect with RL. So now AVVI is no longer equivalent to V out because now you have load, right? Okay. So we need to calculate what is the output resistance R0 for your common collector. So, this R0 is different. The calculation is different. You have to use a formula, and the formula is derived by using a test voltage Vx with current Ix. Okay, so you can see here, this is the whole circuit just now. Okay, and this is the test voltage Vx with the current Ix. Okay, so you can study this if you want. However, eventually you will get this formula for the output resistance of your common collector amplifier. Okay, so this means that R pi over 1 plus beta, this value of resistor, in parallel with Re, in parallel with R0, the small R0. Okay, so that's how you can get the output resistance for your common collector. So back to the example just now, you need to calculate what is R0 over here. Okay, and R pi is given, Re, Rth, and R0 is infinity. So you can ignore this term, alright, and you will only calculate these two in parallel, and you will obtain R0 equivalent to 0.030 kilo ohm. Okay, so now you know what is R0. So now you can calculate what is V out using voltage divider. RL over RL plus R0 multiplied with AVVI. And then VI is equivalent to the value of V1. Okay, and therefore you can get V out over V1 equivalent to 0.963. Okay, so this is an example where, because you have the load resistor, you have to calculate what is R0. Okay, in the previous example just now, you can see that I don't have to calculate what is R0 because there is no load resistor. So that's why I just proceed with the calculation of the gain V out over Vs. So I have mentioned just now, common collector is normally used to amplify the current. So because you have RL, you can calculate what is the current gain. So I0 is equivalent to V out over 4. The voltage across your RL is V out over 4. So just Ohm's law. And for your I in is equivalent to Vi over Ri. Okay. And because Vi is equivalent to V1, so it's just V1 over Ri. We know that I0 over I in is the current gain. So you can see that once you rearrange, you will get the voltage gain over here. So you just multiply with the 3.3875, which is the result of 13.55 over 4. Okay, so this is the current gain. And I simulate the circuit in PSpice, which is a software to simulate circuit. I have obtained these graphs. Okay, so I0 is 285 microampere, I in is 72 microampere, and I get the current gain 3.26. Okay, this is another example where you are asked to calculate the output resistance of a common collector. So you are given all these parameters, and just use the formula for you to calculate the value of R0. So your output resistance is very small, 31.73 ohm. It is in the ohm range. So that's why it is used as current amplifier. So if you have a lower resistor, you will have a higher current. Okay? So this is just a summary. For common emitter, Ri is equivalent to Ri as in the steps. So for both common collector and common emitter, this is the same. However, as for output resistance, for common emitter is equivalent to R0 as in the steps. However, for common collector, you need to use the formula, okay, to calculate what is the output resistance. Okay. Finally, this is a summary for the formulas to calculate AVOC for each type of the amplifier that we have covered in chapter 5. So you can just refer to this for you to calculate the AVOC. Okay, this is for the AVOC. Alright, so you can just use the formulas to calculate the AVOC. So you can skip all the steps and just use these formulas to proceed with the calculation of the voltage or current gain. Okay, so Alhamdulillah, that's the end of the video for common collector amplifier. which means that this is the end for chapter 5. So I'll see you in the next video. Bye. Assalamualaikum.